Hello everyone, welcome back to ANR Academy. This is Nepality sir. Today we are going to discuss number of equivalence relations with the help of Bell number. See, in the last year JE 2025, the questions framed by the concept number of equivalence relations, and there is a short technique to find number of equivalence relations with the help of Bell number. And Bell number can be defined mathematically B of m plus 1 equal to summation r from 0 to m mcr br. Here m plus 1 indicates the total number of elements in the given set. This is mathematical notation. Remember, m plus 1 indicates total number of elements in the given set. Cardinality of the set, that is m plus 1 here. The total here you have, if you have m plus 1 elements, then the formula is applicable. And this is the mathematical notation, whereas Bell number indicates number of ways of selecting partitions of a given set. Let us discuss first that and then we go for mathematical notation. Suppose that there is a set that containing only 2 entries. Now Bell number indicates number of partitions of this set. See here, the number of partitions I can do in this way. Only the set containing element 1, only the set containing element 2. This is one partition, right? And another partition, what I am saying, number of ways of selections, not arrangements, remember. Only 1, 2 and the other nothing is there. So 2 types of partitions are possible when the set A consists just 2 elements. So number of partitions. Selection of number of partitions equal to 2. This is mathematically equal to Bell number 2, that is equal to 2. Let us discuss what is Bell number. Bell numbers are, first you have to write 1 and then the same number I am going to write 1 and sum of these two you have to mention as second element. Next, these 2 you have to write on the third row. Next sum of these 2, 3 and its preceding term, that you have to mention here. 3 plus 1 value, that is 4, and after that 4 plus 2 you have to mention here. 4 and its preceding term 2. Sum of these 2 terms you have to write as the next element. 4 plus 2, here first you have to write 1 and the same number you have to write 1 again, and sum of these 2 you have to mention as second element. This same element 2 you have to write here. Next, third row consists 3 elements. 2 plus 1, that is 3 here. 3 plus 2, that is 5 you have to mention here. Next, The last element in the third row which you have, that you have to write as first entry in the fourth row. The same element here you have to mention. And now sum of these two, 5 plus 2, 7, that you have to write here. 7 plus 3, that you have to write 10. 10 plus 5, that you have to mention as last term. In the same way, you have to continue. You will get bell numbers, and here the bell numbers are 1, 2, 5, 15. You can continue in this way. Why we call these numbers are bell numbers? Let us see. I can write in this way. First number 1, next 1, 2, next 2, 3, 5, and after that 5, 7, 10, 15. It looks like a bell, so that these numbers are called bell numbers. Next, see the mathematical notation for bell number. B of m plus 1 written as summation r from 0 to m, mcr, br. Suppose that A is a set that contains 3 entries. A having elements 1, 2, 3. Then let us discuss number of equivalence relations from A to A are bell numbers. That indicates the value of bell number B3. Yes, A having 3 entries, I can write it as B3, and B3 written as B of 2 plus 1. Okay, B of 2 plus 1 equal to sum of the terms which are product of MCR and BR. Yes, the summation notation I am going to write. R value starts from 0 up to M. So here the value of M is 2, and then you have to write MCR, that is 2CR clearly. 2CR BR. Yes, I am going to continue this. Now B3, number of equivalence relations are bell number 3. First, if you write R value 0, it is 2C0 B0. Next, 2C1 B1. After that, 2C2 B2. Now B3 written as 2C0 value 1, 2C1 value 2, 2C2 value 1. Now you have to mention B0, B1, B2. Bell number B0. B0 1, if suppose there is no element in the set. Number of partitions itself, only one empty set you can write. So number of ways of selecting partitions, only one way. So I can write here B0 value, that is clearly 1. Next, B1. If a set contain only one element, the number of ways of partitions itself, no partitions other than this. So only one possibility is there. You can write in this way. Yes, this is the way of selecting partitions when the set contain only one element. Only you can write one as one partition and the other nothing. Yes, so that there is only one possibility. B1 1. Next, B2. Just now we discussed, when the set contain 2 elements, the total number of selections of partitions is 2. 1, 2, 1 comma 2 one side. So 2 possibilities are here, and so that here B2 I am going to mention 2. Now the value of B3 become 1 plus 2 plus 2, and hence the value of B3 is clearly 5. So the number of ways of writing equivalence relations when a set A contains 3 elements is clearly 5. In the last year JE 2025, the question asked from the topic number of equivalence relations. So that bell number is a short technique to find number of equivalence relations without calculating reflexive, symmetric, transitive relations. Just you have to remember bell number. Bell number gives the number of equivalence relations. I hope you have understood everything. The students, those who are watching my videos, please subscribe the channel and don't forget to like, share and comment. Thank you so much.